Alright, welcome to this new video. In the previous video, we have introduced the concept of Laplace transform, and we have solved some few examples how you can apply the Laplace transform to a polynomial function or to a trigonometric function, okay, exponential function. But in this case, we want to see how we can apply the Laplace transform on derivative, and I think this is the core of this chapter. Remember that when I introduced this chapter, I say that the Laplace transform helps to solve a differential equation, and the differential equation involves derivative, okay? So what is the Laplace transform of the first derivative of the function f of t? So let's see. We can see here that the Laplace transform of the derivative, the first derivative of the function f of t, is s times the Laplace transform of the function f of t minus f of 0. If we move to the second derivative, you see that the Laplace transform is s squared times the Laplace transform of the original function f of t minus s times f of 0 minus f prime of 0. Then if you want to generalize this, we go to the nth derivative, okay? For the nth derivative, the Laplace transform is s to the power n times the Laplace transform of the original function f of t minus f to the power n minus 1 times f of 0 minus s to the power n minus 2 times f prime of first derivative, of course, of 0 minus dash 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 minus f nth minus 1 derivative of 0. This is what we have to know. Now, can we prove this? Yes, it's doable. Let's do that. Explanation. Let's call this first part the first form, this formula 1, formula 2, and so on. So we want to prove this formula 1 and 2. Let's start with 1. By definition of the Laplace transform from the previous videos, we show that the Laplace transform of a function f of t is the integral from 0 to infinity e to the power minus st s of t times dt. Okay, now instead of f of t, we have f prime of t. So if I transform this into f prime, this becomes f prime. Okay, so as I said before, the normal way to write this is to introduce the limit when k tends to infinity of the integral from 0 to k e to the power minus st f prime of t dt. All right, if you use the integration by parts here, okay, what do we obtain? Let's say you let u is equal e to the power minus st, then u prime is minus st. And if you set v prime equal f prime of t, this means v is equal f of t. Alright, this becomes the limit when k tends to infinity of u times v is e to the power minus st times f of t from 0 to infinity. We have the negative sign here. With the negative sign coming from the formula, we become positive, okay? S times integral from 0 to k. We already have the limit here of this f of t e to the power minus st dt. So you can see for this first part, when t tends to infinity, this function will lead to 0. The exponential part will lead to 0. So this will be, this will be 0 minus f of 0. And for the second part, this is the definition. By definition, this is the Laplace transform of f of t. So finally, this is minus f of 0 plus the Laplace transform of f of t. And this is exactly the first formula. So we can do the same for the second formula. So for the second formula, we want to prove this. We introduce a new function, g of t, such that g of t is f prime of t. Okay? So this means g of t is equal f prime prime of t. So the Laplace transform of the second derivative f is the Laplace transform of the first derivative of g, and we know that the Laplace transform of the first derivative of g is already given here, right? is given by the first formula. So this is, if we start with this Laplace transform before we write this, so that it can look like this way. So instead of f prime, we call it g prime. So we apply it here, then we have s times the Laplace transform of g of t minus g of 0. All right, at this stage, if you use the substitution here, g is f prime of t, this becomes s times the Laplace transform of f prime of t minus f prime of 0, right? Again, we substitute this part. What is the Laplace transform of f of t is given here? S bracket s times the Laplace transform of f of t minus f of 0 minus f prime of 0. And if you expand this, we obtain s squared Laplace transform of f of t minus s f of 0 minus f prime of 0. All right, this is exactly the second formula. So we have proven the second formula, and it is easy to prove the nth formula. Now with these two cases, we can use mathematical induction to prove the nth derivative, right? So we can prove this by using the same step. So in general, this fact can be used to find the Laplace transform of the function that are very tricky. So you just have to know how to apply this step. All right, let's use this to find the Laplace transform of a simple function. We let f of t be t cos at. Find the Laplace transform of this function by using the derivative. Okay, I first find the derivative of this function, the first derivative and the second derivative. Let's do that. F prime of t should be, first derivative is cos at minus at sine at. Second derivative of f of t is minus 2a sine at minus a square t cos at. All right, if you look at this second formula, the Laplace transform of the second derivative is given by this. Let's apply that and see. The Laplace transform of f prime prime of t is equal s square times the Laplace transform of the function f of t minus f of 0. So if you find f of 0 here, is this 0? We can skip that. F prime of 0 would be f prime of 0 will be 1. Okay, this is the Laplace transform using the second formula. Let's call this one step 1. This is step 1. For the second step, we want to find the Laplace transform for the second derivative of this function by using this formula. Okay, this is minus 2a Laplace transform of sine of at minus a square times Laplace transform of t cos at. All right, at this stage, we know the Laplace transform of sine at. It is a over s square plus a square minus a square. This is the original function. This is a square Laplace transform of f of t. Let's call this 2. Then if we say 1 is equal to, as you see here, 1 is this second, the Laplace transform on the second derivative. Here the Laplace transform on the second derivative, we have two different formula. If you equate 1 and 2 and simplify, we obtain the following. The Laplace transform of the function f of t will be s square minus a square over s square plus a square. This is the answer. All right, this is all for this video. Thank you.